So in the triangle ABC, we need to find out the value of the given trigonometric expression. Let us begin. So here we will be using the law of cosine, including the law of sine. So let's first state each of them. So here we have a triangle ABC, and the sides opposite to angle ABC are represented by the lowercase letters ABC respectively. Then the law of cosine states that cosine of the angle A, cosine of angle B, and cosine of angle C can be represented in terms of its sides as shown here. Similarly, we have the law of sines, which is the ratio of the side A to that of sine of the angle opposite A equals to the ratio of side B to that of sine of the angle opposite to it. And this is also equals to the ratio of side C to that of sine of the angle opposite to it. So let's now begin. So here we have b squared minus c squared times cotangent of A. Fine. So we can rewrite our first term as b squared minus c squared multiplied to, so we have cotangent of A, and that is the ratio of cosine over sine. So we have cosine A divided by sine A. Then coming to the second term, we have c squared minus a squared multiplied to cotangent of B, so that's cosine of B divided by sine B, plus a squared minus b squared multiplied to cosine of C divided by sine C. Fine. Now we are going to use the law of cosine in the numerator where we have cosine A, cosine B, and cosine C, and for the denominator we have sine A, sine B, sine C. We're going to use the law of sine. Here let's use the fact that if we consider that these three ratios are equals to a constant 1 over lambda, that we can represent sine A as equivalent to lambda times A. Then sine B, that will be equals to lambda times B, and sine C can be replaced with lambda times C. Let's begin. So we have b squared minus c squared multiplied to cosine of A. So cosine of A, that will be b squared plus c squared minus a squared whole divided by 2bc, and from sine A we have lambda multiplied to A. Coming to the next term, we have c squared minus a squared multiplied to cosine of B. So cosine of B, that's given by a squared plus c squared minus b squared whole divided by 2 times ac, and since we have sine B, that will be replaced with lambda times b. Now coming to the third term, so here we have a squared minus b squared, so this will be now multiplied to cosine of C. So cosine of C will be a squared plus b squared minus c squared whole divided by sine C, so that's lambda times C, and a squared plus b squared minus c squared will be divided by 2 times ab. Right. So clearly we see that we have 2 lambda times abc as the common denominator, so we can factor that out. So we have 1 over 2 lambda times abc, so this will be now multiplied to b squared minus c squared times b squared plus c squared minus a squared. So what to do? Let's solve each of them. We're going to get b raised to the power of 4 minus c raised to the power of 4 plus a squared c squared plus c raised to the power of 4 minus a raised to the power of 4 minus c squared b squared plus a squared b squared. Then the remaining terms will be a raised to the power of 4 minus b raised to the power of 4. Then we have negative a squared c squared plus b squared c squared minus a squared b squared. Now here we'll see that couple of terms will get cancelled out. So b raised to the power of 4, c raised to the power of 4, a raised to the power of 4, then a squared c squared, c squared b squared, and a squared b squared. So all the terms within the parentheses cancels out, leaving us with 0. So we have 1 over 2 lambda abc multiplied to 0, which gives us the value 0. So this is the value of a given trigonometric expression.